Right. Welcome to Vidya Velugu. Right. Today we are going to discuss what is pole, polar, conjugate points, and conjugate lines, and also the derivation for the pole, and how to find pole. What is the formula to find out pole, and what is the condition for conjugate lines and also conjugate points. Okay, and what is the formula to find out polar, right? So all these things we are going to discuss right here. So these all are in the circles chapter, we already know, right? Now just see one by one, right? So here first of all we are going to discuss about pole and polar, right? Now we'll discuss about these two, right? Now, so if we want to discuss about pole and polar, we have to consider a circle. So here I am going to consider a circle. Right. So this is the circle. So of certain radius. Okay. And the circle is S is equals to 0. Let us take the circle. Right. S is equals to 0. Right. We already know the notation for the circle is S is equals to 0 here. So here I am going to consider a point which is on the plane. Right. So it may be outside the circle or inside the circle or on the circle. Right. So we are going to see every case, right? So here we are going to see all these three cases. So first of all, here I am going to consider a point which is outside the circle, right? Okay. Now from this point, right, to the circle, I am going to draw the secants, right? So here, so this is secant 1 and secant 2 and secant 3. So just observe here, we can draw infinitely many secants from this point to this circle, right? We already know that one. So here I have considered the 3 secants, right? You can take any number of secants, right? So here I have considered only 3 secants, right? Now just observe here, these 3 secants so intersected our circle. So the first secant intersected our circle at A1 and B1, right? A1 and B1. And the second secant, right? So intersected our circle at A2, right? And B2, right? And the third secant, so intersected our circle at A3 and B3, right? Now here, so what I am going to do? I am going to draw the tangents at these points at A1 and B1, at A2 and B2, at A3 and B3 for this circle only. For this circle, I am going to draw the tangents at A1 and B1, A2 and B2, A3 and B3, right? So let us see what will happen. So if I draw the tangent at A1 to the circle, so it will be like this. So this is the tangent, we already know, right? So next, if I draw the tangent at B1, so this is the tangent at B1. Now just observe here, these two tangents, they intersected at one point. Let us consider that point is T1. Let us consider that point is T1. Next here, I am going to take the tangents at A2 and B2. Now let us take at A2 and B2. So this is the tangent at A2 and this is the tangent at B2. So now just observe, these two also intersected at, these two also intersected at another point, that is T2. Let us consider this point is T2. So this is the point of intersection of the tangents drawn from A2 and B2 with respect to the circle S is equals to 0, right? Next observe here, here just observe. So we are having one more chord here, that is A3 and B3, right? So I am going to take the tangents at this point also. So this is the tangent and this is the tangent at B3. So this is the tangent at A3 and this is the tangent at B3. These two are intersected at one more point, that is T3. Let us consider T3, right? Now, so let us take the the line joining of all these point of intersection of tangents, what will happen? Let us see. So here we are going to take the point of, here I am going to take the line joining of all these points. The line joining of all these points, here I am going to consider this one. So this is the line joining of all these points. So this is the line joining of all these points, right? Now, so this is nothing but our polar. This is nothing but our polar. And here I have taken a fixed point, right? This fixed point. From this point only we are drawn the secants, right? Right. So this fixed point, let us consider P. This fixed point itself we call as pole. Right? So this fixed point we call as pole with respect to this polar. How we got this polar? This is the point of the locus of, first of all, this is the locus of the point of intersections of, right? The tangents which are drawn at the extremities of chords, passing through P. ఒక్కసారి అబ్జర్వ్ చేయండి. ఇక్కడ పోలార్ అంటే లోకస్, ఇది ఒక లోకస్ అన్నమాట. ఏ లోకస్ ఇది? ఈ టాంజెంట్స్ ఉన్నాయి కదా, ఈ టాంజెంట్స్ పాయింట్ ఆఫ్ ఇంటర్సెక్షన్ అంటే ఈ కార్డ్ A1B1 కార్డ్ దగ్గర, ఐ మీన్ ఎక్స్ట్రిమిటీస్ ఆఫ్ A1B1 దగ్గర మనం టాంజెంట్స్ డ్రా చేస్తే ఆ రెండు ఒక దగ్గర ఇంటర్సెక్ట్ అయినాయి. A2B2 దగ్గర టాంజెంట్స్ డ్రా చేస్తే ఆ రెండు ఒక దగ్గర ఇంటర్సెక్ట్ అయినాయి. A3B3 దగ్గర నేను టాంజెంట్స్ డ్రా చేస్తే ఆ రెండు ఒక దగ్గర ఇంటర్సెక్ట్ అయినాయి. సో ఇప్పుడు ఈ అన్ని టాంజెంట్స్ నేను జాయిన్ చేస్తూ ఒక లోకస్ కనుక తీసుకుంటే ఆ లోకసే మనకి ఏమవుతుందంటే పోలార్ అవుతుంది. ఫస్ట్ ఆఫ్ ఆల్ అసలు ఈ కార్డ్స్ మనకి ఎలా వచ్చాయి? ఒక ఫిక్స్డ్ పాయింట్ నుంచి మనం సీకెన్స్ డ్రా చేస్తే మనకి ఏమొచ్చాయంటే కార్డ్స్ వచ్చాయి. A1B1, A2B3, A2B2, A3B3 కార్డ్స్ వచ్చాయి. సో మనం ఏమని చెప్పొచ్చు? ఇప్పుడు A1B1 అనే కార్డ్స్ P నుండి పాస్ అవుతుందని చెప్పొచ్చు కదా. చూడండి, ఈ లైన్ అనేది P నుండి పాస్ అవుతుంది కదా, రైట్? ఎస్, ఇట్ ఈస్ పాసింగ్ త్రూ P itself. Now we can say the definition of the polar very easily. So what is the definition of polar? Just observe here a definition of polar, right? The locus of polar is the locus of point of intersections of tangents drawn at the extremities of chords which are passing through the chords which are passing through fixed point P, right? So this is nothing but polar. What is polar here? It is the locus of the point of intersections of tangents drawn at the extremities of chord which are passes through point P is nothing but our polar, right? Now what is this fixed point we call? This fixed point we call as right, pole with respect to this polar for this circle, right? Now I hope you got what is pole and polar definition, right? Polar is the locus of the point of intersections of all the tangents drawn at the extremities of the chords passes through P fixed point. That fixed point we call as pole itself, right? Now we'll see, just observe here, just observe. Here if you observe pole, here pole is outside the circle we are taken. Pole we are taken outside the circle. And if you observe the polar, where we got polar? If I take the pole outside, I got the polar inside of the circle. Means it intersects our circle at two distinct points. Just observe here. This is intersecting our circle at two distinct points. Let us take this K1 and K2. K1 and K2. Right? Now, just observe. This is also a chord. K1, K2 is also a chord. What is the chord definition? It is the line joining of any 2 points on the chord. Any 2 points on the circle. Right? Chord is the line joining of any 2 points on the circle. Yes, it is also the chord K1, K2. Just observe. K1, K2 line itself, it is the polar. Just observe. K1, K2 is the chord and it is a line, right? And itself it is the polar. Means what we can say? Equation of polar is nothing but equation of chord only. We already know. What is equation of chord? We already know. Equation of chord is S1 is equals to 0. Right? Previously we completed. S1 is equals to 0. Now, if equation of chord is S1 is equals to 0, definitely equation of polar is also S1 is equals to 0. Right? Now, what is S1 is equals to 0? What is S1? What is S11? What is S12? We already seen the notations. Right? Now, we'll tell you again what is the notation for the S1 and S12. So, all these things, don't worry. So, S1 is equals to 0. Right? Now, so here, and one more point you can observe here. Pole is a point. It is not a line. Pole is a point. But polar is a line. Are you getting my point? Pole is a point, but polar is a line. Okay. It is a point. It is a line. That is one more point you need to observe. Right? So this is the case 1. So if I take the pole outside, so this polar intersected our circle at two distinct points. Otherwise we can say that if pole is outside, polar is inside. Pole is outside, polar is inside. So this is the case 1. So if I take the pole outside, so in this way we got the polar, right? Now if I take the pole inside the circle, what will happen? And if I take the pole on the circle, what will happen? Now we'll see. Okay? Just observe this one once. If the pole is inside the circle, what will happen? Right? Now just observe here, I am taking a circle. This is again S is equals to 0. Right. Now here I am considering the point which is inside the circle. So this point I am considering. So here don't take here the point as center. Why? Because we'll tell you. What will happen if I take the inside the point is itself, it is a center. Then what will happen? We'll see later. Okay. Right. Now this is the point inside the circle which is not the center. Okay, right. Now, so again the same concept. So we have to take the chords which are passes through this point. So let us take this point is P. So here I am going to consider the chords, right? So this is one chord and this is one more chord. This is one more chord. And if you want, you can take one more chord also. So this is the right one more chord, right? Now here I have taken 3 chords. So the first chord here it is A1 B1 and it is A2 B2 and it is A3 and B3. Right. So I have taken a point which is inside the circle and I have drawn 3 chords passes through this point P. Right. Now here the same concept again, these two A1 B1 at A1 B1. So we have to draw the tangents again. So here I am going to draw the tangents for this A1 and B1. So this is the tangent at A1 and this is the tangent at B1. This is the tangent at B1. So these two intersected at point, this point, this is the T1, let us take. Right. Next here I am going to take A2 B2 at A2 and B2. So this is the tangent at A2, and this is the tangent at B2. Just 1 minute. Right. So this is the tangent at A2. This is the tangent at B2. Right. Okay, these two intersected at T2. Now let us take here and here. So if I draw the tangent at A3, so this is tangent at A3 and this is tangent at B3. So this is the tangent at B3 and this is the tangent at A3. So these two intersected here. So this is our T3. Right now we already know what is the definition of polar. We already know it is the locus of point of intersection of the tangents, right? So this is one point of intersection and this is another point of intersection and this is another point of intersection, right? Now I need to take the locus of all these three. So locus of all these three itself, it is what ma? Itself it is a straight line, right? Now this is our polar. We already know this is our polar with respect to this point P, and this point P itself it is pole, right? So this is the polar with respect to this pole to this circle, right? So to this circle S is equals to 0. So just observe this one. If pole is inside of the circle, we got polar outside of the circle. If P which is pole itself, right? Pole is inside the circle, polar is outside the circle. You are observing, right? This is the one more point you need to remember, right? Next, sir, you said that don't take the pole as center, right? So what will happen if I take pole as center, right? Just observe here. So if I take here pole as center, means if it is the circle, S is equals to 0, and if I consider this is the center itself, it is the pole, then what will happen? So if I take the chords, so this is one chord and this is one more chord, right? And this is one more chord, right? And this is one more chord, right? Now this is A1, B1, it is one chord, and A2, right? A2 and B2, this is one more chord, and it is A3 and B3, this is one more chord. Now if I take the tangents at end points of A1 and B1, this is nothing but our diameter itself. It is nothing but our diameter. Since it is passes through the center, it is nothing but our diameter. So if I take the tangents at A1, B1, these two are parallel to each other. If I take tangent at here, I will get like this, and if I take tangent at A1, I will get like this. These two will never intersect each other. These two will never intersect because the tangents which are at the ends of the diameter will not intersect. We already know those two are parallel to each other. Since this diameter is perpendicular to this tangent and this diameter is perpendicular to this tangent, these two are parallel to each other. We already know these two will never intersect. Similarly, if you take any two tangents, so if I take at these two, so I will get like this. These two also will never intersect. And if I take here, these two also never intersect, right? So how we will get locus of the point of intersections of the tangents? We will not get. Don't say that, sir, these two are intersected here and these two are intersected here. No, we have to take the chords end points, and at that end points only we have to take the tangents. Those two has to be intersect. But ఇక్కడ మీరు అబ్జర్వ్ చేస్తే ఈ రెండు ends of chord, ఈ రెండు ఎక్కడ కూడా intersect అవ్వవు because these two are the parallel. Since these two are the end points of the diameter, so these two, the tangents will never intersect. That's why we don't have to take here pole itself the center. Okay, we will not get polar if I take center of the circle as the pole, right? So that's why here I said that don't take pole as the center, right? I hope you got this one, right? Now we'll discuss what will happen if I take pole on the circle, right? So we considered the pole which is outside the circle. We got the polar inside the circle. Polar inside the circle. And if I consider the pole inside the circle, so I got the polar outside the circle. Polar outside the circle. So if I consider the pole, right, which is on the circle, what will happen? Let us see. So here only we are going to see, right? Just observe here. Right, now let us consider a circle. So this is the circle, right? This is the circle. S is equals to 0, right? So here I am going to consider, so this is the point which is on the circle, which is on the circle. So here I am going to consider this is P, right? Now this is the pole itself, right? This is the pole itself. Now I need to draw the chords from this point. So here I am going to draw like this. So this is one chord, and this is one more chord, and this is one more chord, right? Now, so this is the center, right? Now here, this is the pole. I have considered here 3 chords which are from this point P only. So let us take this is A1, and it is A2, and it is A3. Now we already know we have to take the tangents at the end points of the chords. So here it is PA1 is first chord, and PA2 is second chord, PA3 is third chord, right? Now here I am going to consider the tangents at these end points of PA1. So here I am going to take the tangent at P. Tangent at P is this one only, because it is the point, on the circle. So this is the tangent itself, right? We already know this is the tangent. Now here I am going to draw the tangent at A1. So this is the tangent at A1. And here I am going to draw the tangent at A2. So this is the tangent at A2. So this is the point of intersection of these two tangents. These two. If I consider this chord, so I have drawn the tangents at these endpoints. So these two are intersected at T1. Now if PA2 is the one more chord, right? If I take the tangents at these 2 points, so this is the one tangent, and this is one more tangent. These two are intersected at here. This is T2. And now if I take here, so this is the tangent. This is the tangent at A3. So these two at A3, this is the tangent. At P, this is the tangent. So these two are intersected here. This is T3. Now just observe the locus itself. It is the tangent. It is the tangent. I think you are getting my point. So this is the tangent, and this locus itself, it is the polar. Means here what we are getting, if I take a point which is on the circle, the tangent from this point P itself, it is the polar. I hope you are getting. Right. Now we discussed all these 3 cases. The first one is if pole is outside the circle, polar is inside the circle, means it will intersect the circle. And if pole is inside the circle, polar outside the circle, it will never intersect the circle, it will never touch the circle. In this case, if pole is inside, polar never intersect, okay, and never touches the circle. Okay, otherwise, and one more, the third case, that is if pole is on the circle, the tangent itself, it is the tangent at point P itself, it is the polar. So ide manaki polar, right? Now you need to remember what we discussed here. Pole is a point, right? Polar is a line. And if pole is outside, if pole is outside the circle, polar is inside. Otherwise, what we can say? Otherwise, it intersect the circle, right? Next, if pole is inside the circle, polar is outside the circle. It will neither touch nor intersects, right? Next, if pole is on the circle, then it is the tangent itself. Polar is tangent at P itself. Tangent at P. These things you need to remember. Right? Now, I hope you got all these three cases. Now we are going to derive, right? What is the notation for polar and what is the formula to find out pole, right?